Hello. Okay, we'll start. Can you all hear me?
Yes.
Okay.
Yeah.
Okay. So, from last meeting, we learned about Arduinos, and then we connected our Arduino using the Tinkercad simulator. So, last week I sent a link for. I'll just show you. But there was a link for a simulator to sign up. How many of you signed up for the simulator? Okay. One person did. Has anyone else signed up for the simulator? It was this one. I'll share my screen. Nishan, do you have a question?
No, I signed up.
Okay. Can you all see my screen? This was the simulator. We were supposed to do this project too. So how many of you have a login for the Wiki?
So, like, if we started a new project, or is it just that we signed up?
Yeah, we signed up.
Okay, I think I did like the whole thing because my screen has like new project, like
Okay,
the plus button with new project.
okay. That's nice. That's good. Has anyone signed up for it? Because if we can sign up for it, then we can save the projects that we did. But
I
if you
think I did.
okay,
My dad did it for me.
okay. So I only see two people that did it out of the out of the seven. So the five that have it, can you do it now? So yeah.
Yeah, but like, give me the website.
Today we're gonna do two things. We'll do the same thing we did last class, but we'll also make a dial. I'll show you.
What's the website called again?
I'll send in a link.
Okay.
Um, I put it in the chat with you. So that's the home page. This is the home page, and then just click. I'm logged in already, but for here it would say sign up, and then you click that, and then it asks for an email and a password. If you have a login, it just helps because you can save your coding in all your projects.
I just logged in.
Okay. Can you all give me a thumbs up once you're signed up or logged in? Okay. Okay, so we'll start. Um, share my screen again. Okay. Can you all see my screen? Hello? Okay, okay.
I
Okay,
can
so
see your screen.
can you repeat that?
I can see your screen.
Okay. So this is the homepage for WikiWi. It's just a simulator and it simulates all of these boards. So you can do the Arduino Uno Mega Nano, the ESP32, which is similar to an Arduino, but it's a very smaller version. And then this is a different circuit board, and then this is the Raspberry Pi Pico, which is a really small Raspberry Pi board. The main difference between these two boards is that the Arduino, it's like a microcontroller. It is a microcontroller, which means you can program it certain things. The best part about an Arduino is that once you give it a code, like once you upload a code, it'll always repeat that code. After you're done compiling and you send the code to the Arduino, all it does is run that code. But for a Raspberry Pi, it's not like a loop. So it's like more like a computer. An Arduino is a controller and a Raspberry Pi is like a microcomputer. And you can like program it. You can have your own computer based on it. Like right now, you're probably on a computer trying, like you open up Google Chrome or YouTube or like have Wi-Fi connected to your computer. A Raspberry Pi, you can also do that, but with an Arduino, you can't. It's just a software that you have to program and upload to a board that you create. So today we're gonna make this LED light up. So if we play it, it turns green, and then it'll be yellow, and then it'll be red. But this time we're actually gonna code it in C++, which is the Arduino language that the Arduino uses. And it's very simple for the LEDs. And then if we get to it, we'll also make a dial, which is also really simple. Yeah, which is also simple. Like I'll run the dial. Just okay. So this is like 0%, but like once you flip it, it's 118, 61%. It's really slow, but it's 189, 74, 56. So this is just a percent dial, but it's like the basics. This is a potentiometer. And then we also learn how to wire the potentiometer, and then program it. But I think the LEDs are cooler, so we did that. Does that make sense?
Yeah.
Okay. If you have anything in the chat, I won't read it, so I might read it like every 10 minutes. But if you have a question, just unmute yourself. Okay. So how do you add parts onto this simulator? So we'll go here. Click on, so this is your home screen. This is the page you should be on. And then click on the Arduino. And then these are all the projects that you can do. These are all the projects other people did and then posted. Click on yours and then click on my projects. And then click on new project. And then scroll down to Arduino. And then click the Rev 3, the Arduino Uno Rev 3. Okay, so this is the screen that you would have. Does everyone have that screen?
No.
Okay.
Yes.
Okay,
Can you show me how to do it again?
sure. Okay, so go to your home page. So do you have this page open? So after you get to this page, just click on your login profile and then my projects. And then I had this project. But if you have any projects, it'd be here. But if you're new, you just logged in, then you wouldn't. Then click on new project and then scroll down to Arduino, or you could just use this slider. And then Arduino Uno Rev 3. That's the board we're using. The Uno is the most common board. And then you should have a screen like that. Okay, So I unshare it. A moment. Okay, so would you want to do what type of code is it? It's C++. Okay, so would all of you want to do the programming first or the wiring first, the circuitry for the LEDs?
Wiring.
Okay, the coding's much
Wiring.
easier for this one, but okay. So let's go here. Okay, so this is an Arduino. Do you all have the screen?
We can't see the screen.
Oh,
We can't see a screen.
Yeah.
okay. Can you see it now?
Yeah.
Okay. So do you all have the screen?
Yeah.
Okay. So this one here. Add the plus button here. The plus button here says add a new part. We're gonna add a breadboard. So type breadboard. Breadboard. So this is a breadboard you would have physically, and then we'll add 3 LEDs.
Which one do I click on? Like the full breadboard, half
Add
bread?
the full one, the full one.
Okay.
Can you show it again?
The breadboard.
No, like what you're supposed to do from when you get to the Arduino.
Can you repeat that?
How are you get? Yeah, how are you supposed to get the breadboard?
Just delete this. Oops. Okay. I'm gonna reload. Whenever the wires are there, it's kind of hard to do it. Okay. So click on the plus button at the top and then type bread. Just type bread. And then it'll say full, half, or mini. And then do full. And then it'll pop up.
Okay, thank you. Yes.
And then type LED.
Take a
You
breath.
did the top.
Wait.
Can you repeat that?
Wait, go there.
You're breaking off.
Okay. Yeah.
You're still breaking off. Okay. So then we type LED, and then there's an RGB LED, and then there's LED. So if you do LED, it's just red. But if you do RGB LED, you can program it a certain color. So like if you turn it white, you can turn it red, yellow, orange, any of the colors. I'll do it again. So go to the plus one and then do LED. And then do that 3 times. And then okay, so once you have the light green showing on the LED, it means it's connected to the breadboard. And then just do that 2 more times. Does that make sense?
How much LEDs are you supposed to have again?
Can you repeat that? Can you
How
speak?
many LEDs ones do you need?
We're just doing 3.
Oh, okay.
Yeah. Okay, once you have the LEDs, then you add the resistors to the positive side. I have a circuit tree paper on this so that it's easier to wire.
Does it matter where we put the LEDs?
Well, you need the LED since we're making this project. Can you repeat your question?
But can we put it anywhere on the breadboard?
Yeah, I recommend putting them farther away because then we'll add the resistors, and then your breadboard is horizontal, right? This is horizontal. Yeah. It helps to have it like farther up because then you can connect it to the Arduino. Okay, so the resistor always goes on to the positive side. Can can one of you tell me which one's the positive, which one's the negative of the resistor? I told you last class, but can anyone guess?
The cathode is the negative and the anode is the positive.
The shorter side is the negative and the positive side is the longer side is the positive. Excuse me. Okay, so if we connect these two, add 3 more resistors just like that. Two more resistors. So on the resistors, there's certain colors on the resistors. So it's like brown, black, red, and yellow. This signifies 1,000 ohms. Ohms is just a unit of measure for resistance, but like depending on how much resistance the resistor has, that's how much bright the LED gets. So if it's higher resistance, the LED glows up less, so it's dimmer. And then if it has lower resistance, if the resistor has lower resistance, the LED brights up higher. But if you have zero resistance, the LED is going to burn out because it's too much current for the LED. For this for this resistor, we have 1 kilo ohms. That's the default. But can you oh
No.
We can't see our screen.
Can you see it?
Yes.
Okay, so here, this is the resistor. The default is 1,000 ohms or 1 kilo ohms. So the resistors, the brands on the colors on the resistor define um what the resistor's value is. Like when you change it to 2, it changes the different colors. If you change it to 3, this one becomes orange, and then this becomes yellow when you change it to 4, green, blue, and it goes so on. But we just need one. Okay, and then now we have to connect these. So when you hover over the prongs of the LED, the positive should say LED 1A. So click on it and then drag it to R1:1. And then do the same thing for the other two. The wire should be red, but we can change it later.
Could you say that again?
So right here, LED 1A, A, connect that to R1:1. So wherever this point is, so how a breadboard works is that under these prongs, under these six, there's six, yeah, under, never mind, there's five. On these five pins, they're all connected to each other. On the bottom, there's like a metal strip under the breadboard that makes all of these five pins connected to each other. These five pins are not connected to these five pins. These five pins are not connected to its friends next door. Like it's only these five pins. So I have LED 1A in the same column as this one, as the resistor. So it's easier to connect to. Does that make sense?
Yes.
Okay. Also, you don't need to use a wire. I'm just making sure there is a wire. Because if you take rid of the wire, I'll show you after we're done programming and wiring. If you take rid of the wires, it'll still work on a breadboard. So just connect the positive prongs to one side of the resistor. And then give me a thumbs up when you're done.
I'm done.
Okay. And
I'm
then,
done.
yeah. Okay, so this is the positive side. So we'll connect this to the positive side. The red, the positive is red, and then the negative, the blue one, is the ground. So we connect this one to positive, and then this one to positive. And then the shorter side, cathode, you connect that one to ground, which is right there. Does that all make sense? Hello? Can you hear me?
Yes.
Yes.
Okay. Okay, so this one, we should change the colors. Um, hello. Doesn't matter what color. Okay, so then this wiring makes all of these wires, they're all connected to positive, they're all connected to ground. Now you have to connect the ground and the positive to a signal and the ground on the Arduino. So that's why you need wires now. So connect the ground to ground, which is right here. And then the positive side, let's connect it to digital pin 2. So we're gonna change the wiring again, but now we can go to the coding. So all we do now is we type the setup and the loop, which is pretty much the setup is the defaults where you tell the Arduino the LEDs are in the digital pin 2. So like we connected it physically, well, on the simulator on digital pin 2. So we have to say that in the setup, and then in the loop we put the main code here to run repeatedly. So it'll never stop. It's a void loop, but it's a while loop. And so this one is where we actually um, turn on the LED, and the setup is where we tell the Arduino. This is where I connected the LEDs to. Does that make sense?
Yes.
Okay, so right now we only have one, although we have 3 LEDs, they're all connected to the same pin, so pin 2. So it'd be pin mode, can you not see this? Uh, can you see the pin mode?
Yes. I see it in your screen.
No.
Uh,
I don't see it in my screen. I see it in your screen.
okay, well, you have to type it, pin mode. You just type pin mode in that, or PIN, all lowercase, and then M is capital, and then pin mode. The pin is 2 that we're connecting to, and then the mode we have to set. So we connected it to pin 2. Well, I did. And then we say 2, and then we say it's the output, because that's the output we want it to be. So the output digital PWM is pin 2, and we want that to be the output, not the input or input below. So output just selected. So that's the output. Since we're taking information in, and then the output should be that the LED turns on. So that's why pin 2 is the output. And then that's it for the setup. And then here, is everyone cut up?
No.
Okay.
Can you say the code again?
Can you see my screen? It's just pin mode, parentheses 2, comma, output.
Oh, okay.
You can split your screen, like have zoom on your left side, and then whatever browser you're using on the right side. So then you don't have to open and close the browsers. Okay, and then to turn it on, we use digital right. Digital right, and then it's 2 because we connected it to 2. And then we have 2 options, high or low. High is 1. The Arduino understands high as 1, and then since Arduino is a microcontroller, it runs on zeros and ones. So high to the Arduino is 1, and then low is 0. High for us means turn the LED on, and then low means turn the LED off. So we're gonna do high first. And then we want to delay it for like half a second. The Arduino, the time for the Arduino, it's measured in milliseconds, so the thousands. So delay, and then say 500. And then after every statement, you have to put a semicolon. So we forgot to put the semicolon here. But we put a semicolon everywhere. And then we delay it for 5 seconds. And then we can turn it off again for 5 seconds. And then you can repeat it. And that's the loop. Change this to low. Oops. And then that also delays. Then we can start running the program. So they all turn on because they're all connected to pin 2. And then they turn on and off at the same time for 500 milliseconds or half a second. Does everyone have this?
No.
Okay. If you need help, you can share your screen and I'll help you. We did this last class, but we didn't do the actual coding. We did the blocks. So I just wanted to help you see the difference between the blocks and programming. It's very similar. It's just you need to know the syntax, and that's it. To make, I'll stop that. But to make the LEDs blink in order, like red, orange, and then yellow, not at the same time. We we just have to change the pins. Um, can I share my screen? Yeah, you can share your screen. I'll stop sharing. Okay.
So when I say uh simulate, it's saying build fail. I don't know what I did wrong.
Okay. So the code. So let me see your wiring. So some of your wiring, you have the first resistor on your left. There's an empty pin. So like it's not connected. It keep on going up.
Oh yeah.
Yeah. Connect that to positive. Okay. And then let me see. Did you flip the last one, the blue LED? Did you flip the prongs?
Yeah, that.
Okay. Okay. That's correct. And then this one's okay. So all your wiring is correct. And then if you go to your code, it's still wrong. Your code is wrong. You see the pin mode 2, comma output, and
Yeah.
the semicolon. Can you copy all of that? Not the whole thing. The starting with P on pin mode, and then all the way to the semicolon. Copy it, and then delete it. And then go to setup. It says put your setup code here to run once. Yeah, so hit enter, and then control V. Okay, and then go back to void loop, and then type a curly bracket, an open curly bracket. No, like the actual curly bracket, not
Oh.
like text, yeah. Because if you see, The curly one. The one,
Oh.
yeah. Yes, and then hit enter. Okay, so now you have the digital write to high um, semicolon. Copy all of that. Lines 11 to 14. Copy all of it and then paste it where you have your cursor right now.
Do I delete this?
Copy and delete, yeah. No, you pasted it in the wrong spot. So
Oh.
you have to delete it again. Go up. Move your cursor up. Hit enter.
Right here?
Yeah, hit enter. And then control V. Okay. And then there are two curly break. So the code you just copied, there are two curly braces inside the code that you just copied. Delete those. Lines 9 and 11. And then also delete 9 and 11. Yeah. Delete the curly braces on 11.
Yeah. Oh.
No, you deleted the wrong one. Do control Z. Do it again. Yeah, okay. Yeah. Go to line 11 and delete that one. Okay. And then you have to indent 9, 10, and 11. So hit tab. And then do that for 9 and 10. And then your code should work.
Okay.
Okay. So you can run it. Yeah, it
Okay.
worked. Okay. So
Thank you.
I
Yeah.
need help.
who needs help?
Pranav. Me.
Okay, Pranav, you can share your screen. So from the previous forgot who it was, but from the previous person's example, just remember that you have to indent your code. Like I made him do tab 3 times, 9, 10, 11. That's important. Like in coding, you have to indent it to make sure that your code is inside the loop or inside the setup. Okay, what's your question for now?
So yeah, it's kind of the same problem. It's like
Okay,
this.
okay. You can close out of it.
Question.
So you have the same thing. Your first resistor on the right side, on the left side, yeah,
This
that
one?
yes, it's not connected to the positive. Yeah, click on it and then go to positive.
Question.
I'll get to you after I'm done with this one. Okay, just remember to ask again. Okay, and then this one's right down there. Okay, all of your circuitries right. Okay, your coding is pin, okay, so pin mode 2, and then output, the O is on the output, the whole thing has to be on the same line. Yeah. And then I think you have an extra space. Yeah. And then, okay, so you deleted your end curly braces. Okay, so move your cursor up one space. Go to line 4. And then type in closed curly bracket. No, like the actual curly bracket.
Oh.
That's a parentheses. This is a curly bracket. I sent it in the chat. That's a closed curly
Oh.
bracket. Yeah. Sorry.
This one?
Yeah.
Oh.
Okay. And then go back to line 3, and after the last parentheses, you have to add a semicolon. Yeah. Okay, and then your void loop. So everything's right, but just after the 12th line, hit enter. And then do another closed curly bracket. Okay, and then just like before, the previous person, he didn't indent any of his code. So all of the code, I'll share my screen. Can you stop sharing?
Yeah.
Okay, so you can all see my screen, right?
Yes.
Okay, so no one's code will ever work if it's on the same line. So the curly braces define that void setup, everything in the function void setup inside the curly braces, they all have to be indented. So none of your lines, so none of your lines are indented, just so like they're like that. Just hit tab for all of these lines. And then it should work. So
Okay.
also on setup, you have to do setup too. So if yours was like that. Okay, so it should be indented. And then it should work.
Yeah, it's working.
Yay! Okay. So someone else has a question. Nashant, was it you? You can ask your question.
I found what I did wrong.
Okay.
I need help.
Okay, you can share your screen.
Uh, I shared my screen.
I can see it. Okay. So I'll check your wiring first. All of your wiring's correct. Good job. So the void setup, the pin mode, the M on pin mode has to be capital.
Yes?
Yes.
Uh,
Yes. So you see the color change before, like with lowercase m, it was black, but now it's red when you do capital M. That's the syntax. So every time you have something wrong, it'll have a different color. So if you have like digital right, all of your delays in digital right, they're all red, so it's a syntax. So pin mode is also has to be red. Okay, and then after the comma on line 2, you have to have a space, and then output has to be all capital. So just click on output, and then delete all of it, and then type output in caps. Yeah. Okay, and then you on line 5, delete the curly bracket. Nishant, I'll share the screen, yeah, after sharing. Okay, and then void loop. So all of this is right except for 9, 10, and 11. They have to be indented. So you have to hit tab. Indentation is very important. Yeah, and then it should work. Yay, it works. Okay, I'll share my screen, Nishant. Can you see it?
Yeah, I can see it.
Okay. Do you need any specific help on anything?
No, my code just deleted somehow.
Oh, okay. So, um, we're gonna change your code anyway, so it's okay. So now we'll do a Christmas, like once the red one lights up, after it's done, we'll make the orange one light up. And then after the orange one lights up, we'll do the yellow one. So this one requires different pins. So the red and orange and yellow are on the same pin. On digital right 2, they're all on the same pin. Now we're just gonna make them on different pins so they light up like in a rainbow color. So all we have to do is change the positives of the pins. We have to delete these wires. So hit delete. I have to stop running. Okay. So hit delete for these the wires that connect to the positive. Oops. Okay. So this one. Hit delete. Okay. Okay. So once you've deleted those 3 wires, we go here. We also have to delete this one. So for the Arduino, the voltage depends on what you're connecting. LEDs, they don't require much voltage, so we're just going to connect any positive side. Well, actually, so we connect the 3.3 volts to the positive side, but since the LEDs, they require very little voltage, we can just connect it to the signal pin, and then we wouldn't have to connect any voltage pins to the LEDs. So let's make the red one 2, or yeah, we'll make it 2 again. And then we'll make the orange one 3. And then, so you see like your wires are not, they're like all um, on top of each other. It's okay. Just make sure that once you hover over it, like click on it and then hover over the actual pins that you want it to connect to. So 2, yeah. So we're gonna do 2, 3, and 4. And then we change our code. So now what we do is pretty much copy and paste. We already have the code for 2. Now we just have to make the code for 3 and 4. Pins 3 and 4. And then it'll light up in the order we tell it to. So right now we have 2 as the first one. If I switch it to 3, the orange one will light up. So this is 2.
Question.
Okay.
Like, I would like to know, like, what is the difference between a robot and a rover?
You cut off. You said what's the difference between what?
I said, what's the difference between a rover and a robot?
A rover and a robot?
Yeah.
Okay, a rover is more like it depends on the actual mechanics. Like when you think about the mechanics of it, a rover is where it's more like treaded, like the wheels. It's like based on the wheels. A robot, dependent on the robot, it has wheels or legs. A rover is more of a task based. Like a robot, it can talk, it can speak. It's more human based. So it's more multitasking. A rover is more of a car based. It's like it's one type. You can do one thing with a rover. Like you can drive it to a place and one thing. A robot, it'll do multiple tasks. Depends on what you program.
Okay.
Yeah.
Thanks.
So you're welcome. So did I turn off my video? Uh, so then all we do is copy line 3. For mine is line 3. So just copy this, hit enter, and then paste, and then do it again. Then we change 2 to 3, pin 3, change pin 2 to 4. So the 2 represents the 3, the pin 2 we connected to the LED, the red one, and then pin 3 we connected to the orange one, pin 4 we connected to the yellow one. That's why we have 2, 3, and 4. These, we're basically initializing these. We're telling the Arduino, hi Arduino, I connected the red LED to pin 2, the orange LED to pin 3, the yellow LED to pin 4. Does that make sense? How do you connect the wires? So you just hover over them. Oops. So I'll share my screen. I keep undoing this. Okay, so let's delete this one. This one was pin 2, I think. So whenever you're connecting something, so like you hover over this, click on it, and then drag it to whatever point you want. So I'm clicking on it, and then I'm hovering over it, and then I stop, and it's done. Does that make sense? It doesn't do anything. This wire doesn't do it. Does that make sense?
Yes.
Okay, so I'll undo that.
Can I just like share my screen once to see if I got everything right?
Yeah. On your wiring side,
On like both.
okay, we're not done with the programming side. So if your program doesn't work, then you could ask, because we're not done with the programming.
Okay.
Okay. Since it's 10 a.m., you can leave if you want. I'm gonna stay until we finish at least this part because I really want to do the dial too, but it's boring. So I'm doing the LED. Let me see. I can. If you want to do, so I'm gonna finish the LED project right now. Um, and then I'll do the dial if you're interested in doing the dial. And then we're done. So you can leave if you want. I'm just gonna continue. And then so Arnav, not like the connect positive things. Not like that, like I don't get your question in the chat. Okay. So where did it okay. Shit. So for the programming, all we do now is copy again and then paste it 2 times after. And then change the digital write pins to 3 and 4. So these 2 are 3, these 2 are 4. Then we're all done with the coding and the wiring. See if they run. So the red one lights up. Then the orange one should light up. Yay! And then the yellow one lights up. 500 milliseconds is too slow. And then it repeats. So if your program doesn't run like this, you can ask questions and share your screen. I'll copy the whole code in and paste it in the chat. But most important things is indent, make sure there are curly braces. Whenever you're on the curly braces, it highlights the other end of the curly brace. I'll stop this. So make sure everything's closed and then everything has colons and everything has, if it's like C++ is case sensitive, so it has to have lowercase or uppercase letters. But if you have programming errors, I'll copy this code and put it in the chat.
Mine says when I started the thing, it said I had like some error.
Can you share your screen?
Okay.
I'll help you with the code even if I paste it in the chat. I pasted the code in the chat.
Do you see my screen?
Yeah.
Okay. 1 second. So if I press this, it says,
Okay. So can I see your code? Can you scroll up? Okay, so on your coding, everything's nice except for go to line 6 and then type a closed curly bracket.
okay.
And then for 3, 4, and 5, they have to be indented. Oh wait, so a closed curly bracket is that.
One
Only,
second.
yeah, I typed it in the chat.
Okay. Should I stop sharing?
Okay, so 3, 4, and 5 you have to indent. Not a space, an indent. An indent you have to hit tab.
Okay.
Yeah. I'll be right back. One moment.
Okay.
Baba.
Okay, I'm back. Sorry. Okay, so on line 6, you have an open curly bracket and a closed curly bracket. You only need the closed one. So delete the first one. Okay, can you mute yourself, please?
Okay.
Not you, someone else. I forgot who it was. Okay, so then on line 10, you have a space right before the D. So delete all of that. Just hit delete, okay, and then hit tab. Hit delete, yeah. And do that for all of them. Okay.
And then hit tab for all of them.
No, so wait, go back. Okay, so highlight line 10 to line 23. Like select all of it. Okay, and then hit tab. Okay, and then on line 24, enter a closed curly bracket. The same thing on line 6. The same thing that you did on line 6, do on line 24. Okay, and then your wiring's off. Your wiring, you didn't change your wiring. Okay, so all of your grounds are good, but delete the. Can I share? Can you stop sharing your screen?
Okay.
I'll share it. Syria, I'll answer your question right after this. Okay. Share. So you can see my screen, right?
Yes.
So these wires, the ones that are vertical that are to the right of each of the resistors, delete all of those 3 wires. Delete those 3 wires. You just hover over them, select them, and then delete.
Okay.
And then you have to connect them to pin 2, 3, and 4. Your connections are wrong. That's why the LED didn't light up. And then once you're done, if it still doesn't work, you can share your screen again.
Okay.
Yeah. So delete this one. Like my wires are connected to the Arduino. Yours are connected to the positive. You want them to be connected to the pins. So it doesn't matter which order, but 2, 3, and 4. Yeah. Someone else had a question. Siri, I think it was Siri. Yeah.
Yeah.
Okay.
I'm like, will we learn how to make two light up at once and then the other one to light up?
Can you repeat that?
Will we learn how to light up two at once, then the third one to light up again, like the
Yeah,
third one to light
you
up?
can do. Yeah, you can do that. Do you want me to show you?
Yeah.
It's very easy. So all you do is you delete. So let's say red and orange are connected to 2, and then the yellow one is connected to 3. But we'll just leave the yellow one alone. And then, so the yellow one's connected to 4 on mine. All you do is delete one of them, delete one of the wires, and then connect to, it's not, undo. Okay, so select the yellow one, the resistor, and connect it to pin 2. It's the same pin the red one's connected to, so they both light up. Pin 2. And then you can delete the pin 3, or you can comment it out. Oh, I forgot to tell you about comments. Comments, so these are comments. Put your main code here to run repeatedly. These are comments. So this is English, but these are just codes that help the programmer understand what's happening in the code. So whenever you hit select something and you hit command or control and then the slash button, then it'll comment this up. So if you hit run, the red and orange one should light up at the same time, and then the yellow one lights up later after they light up. Yeah, so it lights up and then it repeats. Does that make sense? You just connect the red and the orange one to the same pin.
Mm-hmm.
That's it. It's very simple. Does that help?
Yeah.
Okay. Um, does anyone else have questions about lighting up the LEDs in order, like red, yellow, red, orange, and then yellow?
Can you just show me your screen one more time? I just want to see if my code.
Okay. I pasted the code in the chat so you can check it. Like you can copy it.
Okay.
But I shared my screen.
I'm just saying if I put them in the right line.
The order, yeah, okay. So this one, I'm connecting mine back to 3.
Okay. I'm good. Thank you.
Okay, we'll do the dial now. How many of you are staying for the dial?
My lights won't light up in the Arduino.
Okay, you can share your screen again.
Can you see my screen?
Yeah. So all your code is right. It's just your wiring. Okay, so this one's right, this one's right, this one's right. So can you run your program?
Okay. Like it won't light up at all.
Okay, so can you delete? I wish I could point. The wire to the positive side of the wire on the breadboard. Yeah, delete that one. Okay.
Here?
Okay, and then could you delete all of the ones? No, don't do that. Delete that. Okay. So then delete. I'm gonna make you delete 3 other wires because I can't tell which pins you connected it to. So
This one?
yeah, that one and then the other 2. Yep. Okay. So go to your first resistor and then click on it and then drag it to pin 2.
Here?
Yeah, and then click on it. Okay. And then do the second one and then drag it to pin 3. Yep. Uh, yep. Okay. And then the last one, drag it to pin 4. And then your code should work.
Okay. Do I have to add a wire here?
Oh yeah. Yeah. The ground one.
Okay. From here? Negative?
Yeah. And then go to ground. Yep. Yay. Yeah, you were right. It works.
Okay.
Yay. Okay.
Thank you.
You're welcome. Siri, what's your question?
I'm like I'm trying to make two light up at the same time, and the other one to light up after, but it's not working.
Do you want to share
Can I
your
share my
screen?
screen?
Yeah.
Mm, I'm tr-
Yeah,
I'm trying to make the red one and the other red one to light up at the same time and the green one to light up at another time.
okay. So it depends on your connections. So the first one's connected. Can you zoom in on your breadboard? Thank you. Okay, so the first one's connected to this one, and then this one is connected. Okay, it's two, and then okay. So go to your code. Go to line 20,
920, yeah?
and then the 4. Change that to a 3. Do the same thing for 23. Because on your wiring, you don't have anything connected to pin 4. You have it connected to pin 3.
Oh,
Yeah,
okay.
try doing it now. Yeah. Yeah,
Yeah.
that was it. Does anyone else have any questions? Do you want to stop sharing your screen? Yeah, thank you. Okay, so I'll do the, how many of you want to do the dial? I want to do the dial.
Okay.
Okay,
I'm gonna do the dot.
you do?
Yeah.
Okay, so I have to share my screen. The dial is pretty easy. Share screen. Okay, so this is the dial code. The wiring for the dial,
So do I have to like save this project?
yeah, hit save. At the top, it'll say save. Hit save.
What do I save for like the project name?
You could do LEDs or something like that. And then hit save. And then it should save.
Okay.
Yeah. So
Oh,
after you save it, go to my projects and then do the same thing where we create a new project. So new project, and then go to Arduino Uno. We'll use the Arduino Uno throughout the whole class.
Okay, I did that.
Okay, yeah. And then we'll do the wiring. The wiring's really easy. I have to yep. So for the dial, we're using a potentiometer, which is pretty much like a switch, not like a switch, but like more like a dimmer. Like you have a light and you can tune how bright the light is. A potentiometer is kind of like that. But
Okay.
yeah. So type PO, and then the first one is
Yeah, I got it.
okay. And then on the little pins, the 3 pins, it says GND, which is ground. SIG is signal. And then the last one is VCC, which is power. So ground, we always connect it to ground on the Arduino. Signal, we'll connect it to the analog pins on A0. So we go to A0 right here. And then VCC will connect it to 5 volts. It can go without, it can go with 3 volts, but we just want to do 5 because it'll have faster speeds. That's all there is to the circuitry. And then the coding gets a little complicated, but it's okay. So we have variables in programming, and we're just going to make 3 variables. So variables don't have to be in any of the functions.
Okay.
So I'm getting out of the function, and then I'm going to type CONST.
So do I have to like delete the void setup and
No,
everything?
no, no. You still need those. It's just we're going to type everything and set up and loop later. We're just going to use the variables first.
Okay.
Yeah. So const is a constant. We don't have to add it, but I add it because a constant is just something, a number that doesn't change. And we're just going to assign a variable to, we're going to assign a number to a variable and it'll always stay constant. So the number will never change. So we type constant and then we type int because it's a number, an integer, and then we type whatever we name the variable name to be, and I'm gonna name it pot pin. I'll just name it pot pin because it makes more sense. So pin, and then set that equal to A0. It's A0 because we connected it to A0 right here. That's the same pin, the signal pin, that's A0. The pin, we're gonna say signal pin. Signal, signal pin. Signal pin is to A0. And then we have another one, constant int. And then we have mins. So capital M min. That's the minimum, which is 0, for like a percent dial. And then semicolon. And then we do the same thing for maximum, constant int, and then capital M max. And then that would be a special number. That's a special number. And then that's 1023. That's the variable, like how much turning the potentiometer can have. How many people are, okay, there's 5 people. So the coding's pretty simple. So for setup, all you do is serial dot begin, and then these are so this simulator, it has the wiring and the coding. When you actually have a physical Arduino, you have to have a software. You have to install a software called Arduino CC, like the IDE, the Integrated Development Environment, and you code on that. And then when you code on it, you have sometimes when you get an error and you don't know what the error is, you can make the Arduino send messages where it says, oh, you have an error, this is why, or you have an error, this is why. So this serial begin, this helps with that. This is the serial number that it starts off with. There's other numbers, like,
What
there's,
number do we have to put there?
can you repeat that?
What number do we have to put
We
there?
put 9600.
Okay.
Yeah, but so like in Arduino, there's multiple, it's like called bandwidths, and there's multiple of it. In the simulator, there's just two. So we're using the 9600, but this helps with when we get an error or something. But the serial will begin, it just makes the Arduino say that, okay, the program started running. Okay, so, and then we hit tab. Make sure you're hitting tab all the time. So then we hit int sensor sensor value is equal to analog read. So the A 0 that we connected to, A means analog, and then everything at the top of the Arduino is like digital PWM, like right here, digital PWM. These are all digital pins. These are all analog in. So A is analog. So analog read. So it reads this pin. It reads A0. So then it would be the signal pin that we put in.
Can you put the code in the chat? I can't really see it on your screen.
I'll zoom in. Can you see it now? I'll put it in the chat too. But I want to make sure that you type it because that's how I learn. If I copy things, I don't learn. But can you see this now? Hello?
Yeah.
Okay. Yay. So that's the signal pin. This signal pin is this pin. That's why we have variables. We could have just typed A0 instead and it still worked. But we have variables. So every time we don't have to type A0. It just makes it easier. That's why we have variable. Signal pin. Okay, so make sure you're indenting and having semicolons. And then we have another integer. And then this is the most important. The percentage of how the dial is, it's on a map. So this is what the map does is it makes sure that it's okay, so it's connected. So the dial, this is like a map. It makes sure where it is on the dial. This pointer, where is it on the dial? That's the map. So we do sensor value. And then we do min and max. Min and then we also do 0 and 100. So the 1023 is the actual max that you can have, but on a percentage, it's 0 to 100. So we make it sure it's 0 to 100. So it reads 100 to 0, 0 to 100. It does not read. The dial does not read 1023. It does not go over 100. And then this is just easy part. We do serial print. So in different languages, you've always like the basic coding. You do hello world print, like simple things. So we're doing that, but we're just gonna print the percentage instead. So print ln and print are almost the same thing. Print ln just means you're gonna print on the next line. You don't print on the same line. So print and then you do percent quotes and then type percent because we're doing a percent and then hit a semicolon and then actually print out the percent serial dot print and then you type percent. This is the variable that we just made, semicolon, and then we can do ln if we want to. Serial dot print ln.
Can you go a bit slow, please?
Okay. So where did you stop coding? Where did you lose me?
I'm on like line 17 right now.
Okay. We're almost done, so yeah.
Okay.
And then we just delay that for half a second. And that's it. So again, make sure all of your lines are the lines inside the setup of the loop are indented. Make sure you have I do not have a semicolon. Make sure you have a semicolon everywhere. I don't have so
What is that symbol on line
18.
18?
Yeah, it's a percent sign. So shift 5%.
Shift what? Shift 5, okay.
Yeah, for the percent, yeah. So if you run it, it's at 0%. So 100%, 76. So okay, I have way too simple. Okay, so this is the screen that you have to have it in order for the potentiometer to work.
Mhm.
So this is 0. This is 26, yeah. 40. 92. 8. It goes from there. So the dial, where's 0? Okay, so this is 0. Do you have a question?
What do we do with the like thing on the top?
This?
Yeah.
Yeah, so you have to move it. You have to hold on it and then move it around. And then at the bottom the percent changes based on wherever this is.
So do I have to start the simulation and then move it?
Yeah, yeah.
Okay.
So this is 0.
It says I have an error.
Do you want to share your screen? I'll stop
Yeah.
sharing.
1 sec.
Yeah, I'll put the code in the chat.
Share. Share. Can you see my screen?
Yeah. Okay. Can you close it? Okay, so all of your wiring is right. Let me see what your code's wrong.
Did I miss tab anywhere?
Okay, so 2, 3, and 4, you don't have to have a tab.
Oh, I don't. Okay.
You only have a tab when you're inside setup or loop.
Oh, oops.
Control Z. Yeah, and then manually do it. Yeah. Okay, and then everything seems right except okay, so for 13 signal pin, the P is capital, but on line 2 the P is not capital, so those two have to match, lowercase a numbers. So just yeah, to lowercase, yeah. And then okay, and then line 17, the percent, you have to take the quotes out and the colon. Delete the quotes and the colon.
Okay.
Because that's a variable, not a text, not a string.
So do I have to have any space in it?
No.
Okay.
That's it. Try running it. Ooh. Let's see. Percent. Percent. Ooh. Also have line 18, the print, you have to have L in after it.
L.
And yeah. Enter value maximum. Everything.
There's the parentheses again. Do I have to delete the parentheses?
Yeah, yeah. Try running it now. Hold on. As expected before. Oh, okay. Close out of it. On line 13 and 14, you don't have a semicolon at the end. Yeah. It should work now. Yeah, it works. Okay. So the middle left is 0, and then the middle right is 100. Okay. Do you want to stop sharing your screen?
Yeah.
Okay. Siri, do you have a question?
It's not a question. I just noticed something.
Yeah.
Can I share my screen?
Yeah.
over here you see these percentages, right?
Yeah.
Well, they're just making more. When I click this, it's just the same thing, but the percentages is just is the like the code for this.
Can you repeat that?
The percentage, the percents you can see over here, it's like the code for this. Whenever I
Yeah.
move it, this thing keeps going the way I point it.
Yeah.
And it says the same percentages over here.
Yeah.
Can I share my screen? It says I have a wrong build.
Yeah, sure. Okay. So on line 4, after the equation, have a space. It's not an error, but it's like it's syntax. And then after the 3 on the same line, you have to have a semicolon.
Oh, yeah.
Can we leave now if we're done with this?
Yeah. Yeah.
Okay. Bye.
Bye. And then 8, you have to have an indent. So tab. And then go to line 6 after the last parentheses. And then hit space and then enter a open curly bracket, curly bracket. And then delete the one to the right. Yep. So, because it just highlighted, you have to have both of them, the open and close. And then signal pin. Okay, so line 13, it has to have signal pin. So go
Oh,
to, yeah. And the P is lowercase in line 2, so it has to be lowercase in there, yeah. And then sensor value, max, min, 100. Everything else should work. Oh. Oh, okay. Also, go to line 11 and then also type an open curly bracket. Yep. Yep. Delete the, yep. That's it. It should work now. Yeah, that's it.
okay. Thank you.
You're welcome.
Bye.
Bye.